Hi and welcome to Math Pre-Calculus 20, Section 7.3, Absolute Value Equations. Right, so as soon as we see the word equations, right, we're looking for something like x equals something, or whatever variable we have equals something. So we want to solve this equation here in example 1 of the absolute value of x minus 3 equals 7. So basically, we want to know what values of x, right, make that equation equal 7, or make that side equals 7. So is there one value, are there two values? So one way we can do this is by graphing. So yesterday we looked at graphing absolute value functions. So we could graph y equals absolute value of x minus 3. And basically we could also then look for how that intersects with the equation y equals 7. So we take these two things and find intersection. And the intersection we're interested in, we're looking at, okay, what are the x values when they intersect? Okay, so graphing this here, how did we graph this? Well, yesterday we saw that we could actually just graph y equals x minus 3 and then do that reflection thing. So y equals x minus 3. Here's our x, here's our y. So it has a y-intercept of -3. And it goes up 1 over 1, it's got a slope of 1, up 1 over 1, up 1 over 1, like that. We can graph that. Okay, get something like that. But as we recall from yesterday, an absolute value function, right, doesn't end up down here. Right, what it actually does is it reflects above the y-axis, or above the x-axis with that shape. So it's going to be like this. Okay, so the actual part of the graph, right, goes something like this. My axes are a little bit funny, but it should be something like that. Okay, so then this bottom part of the graph here, right, doesn't actually exist, so I could delete some of that stuff there, shorten this up, right, and there's our graph of y equals absolute value of x minus 3. And so what we want to know is, okay, when are the values of y equal to 7? So we can just graph a line across there of y equals 7. So it's 1, 2, 3, 4, 5, 6, 7. Right, so here's the line y equals 7. And we find, okay, where does it intersect? Well, it intersects over here at the point 2, 4, 6, 8, 10. So this point is 10, 7. This point, 2, 4, -4, 7. Right, so what are the x values that make this equation true? Well, the x values are x equals 10 or x equals -4. And we could put those into the equation there and just verify. Right, so if we go up here, if this is 10, right, is that true? 10 minus 3 is 7, absolute value of 7 is 7. Yep, that one works. And -4, take away 3 is -7, absolute value of -7 is 7. Yeah, that works. Okay, so that's one way of doing this. Probably not the easiest way of doing it, but it's one way of doing it. So a second way we can do this is solve that same equation, but instead just use algebra. Right, so using algebra. So our equation again was what, x minus 3 equals 7. So absolute value of x minus 3 equals 7. Okay, well, this one's a little bit complicated. What if I were to ask you the absolute value of x equals 2? Okay, what would be the possible x values there? Well, we know x could be 2, but if we think about it, x could also equal -2. Same idea applies here, and it's really handy. These are really easy to solve once you get the idea. We know that x minus 3 must equal 7, or -x minus 3 could equal 7. Right, so the key is make sure that you put brackets around that there, because that negative sign is going to distribute. So then solving this, we've got this top one, x equals 10, right, we added 3. And this one here becomes -x plus 3 equals 7. We subtract the 3, we get -x equals 4. and then getting that negative to the other side, x equals -4. Right? Same solutions we got by graphing it, but a lot quicker method. Okay, so we could do it by graphing or by algebra. Generally, we're going to do this by algebra just because it's so much quicker and simpler. Okay, thanks for watching.